Okay, see the problem. So based on volume of hydrogen, volume strength of hydrogen peroxide, and also having the concept milli equivalence. Here, 100 milliliter of hydrogen peroxide is titrated. Titrated means nothing but an adding process, which is added to an excess potassium iodide. Means it is reacted with potassium iodide. Where the hydrogen peroxide oxidizes the potassium iodide into iodine in acidic medium. So the liberated I2 need, the I2 is liberated, means potassium iodide is oxidized to iodine. So how much iodine? It is not given. That iodine requires 50 milliliter of 0.1 m sodium thiosulfate solution for its complete reaction. We need to find the percentage strength and the volume strength of hydrogen peroxide. Here there is totally 4 compounds are given. At first the hydrogen peroxide reacts with potassium iodide, which changes potassium iodide into iodine, and this iodine requires sodium thiosulfate for complete reaction. Means H2O2 reacted with potassium iodide forms iodine, and that iodine is completely undergoes reaction with sodium thiosulfate. Means so here information. So on these reactions we can write milli equivalence of hydrogen peroxide is exactly equal to the milli equivalence of potassium iodide, because these two are reacted at first, and the iodine is liberated from these compounds. So here we can write it is exactly equal to milli equivalence of iodine, and this iodine totally completely reacted with this thiosulfate. So we can write milli equivalence of sodium thiosulfate. All are interlinked with each other. But here information is given only about hydrogen peroxide, the 100 milliliter of hydrogen peroxide, and there is no information about iodide. There is no information of iodine, but the information is given about sodium thiosulfate. So here we can write now milli equivalence of hydrogen peroxide is exactly equal to the milli equivalence of sodium thiosulfate, or we can write in terms of the reacted part in this is thiosulfate. So no problem, we can write Na2H2O3, or the reacted part H2O3 minus 2. Okay, so milli equivalence, we know that N1 V1 equals N2 V2. So what is N1? So to know the strength or volume strength, it is compulsory to calculate the normality. Okay, normality of hydrogen peroxide find out cheste. My basic formula, 1 normality of hydrogen peroxide is equal to 5.6 volume strength of hydrogen peroxide, 1.7 percentage of strength. అంటే ముందు హైడ్రోజన్ పెరాక్సైడ్ నార్మాలిటీ ఫైండ్ అవుట్ చేయాలి మనం. Normality into what is this volume? It's 100 milliliters. N2. So what is the normality of the sodium thiosulfate? Normal molarity is given. Normality equal molarity into its N factor. Sodium thiosulfate N factor is 1. We will see it later. What is volume? 50 milliliter. So normality equals that is equal to 0.05 normality. This is normality of hydrogen peroxide. So after knowing this normality, and we know that formula, with basic formula, that 1 normality is equal to 5.6 volume strength of hydrogen peroxide. Then simply what about 0.05 normality is equal to how much volume strength of hydrogen peroxide? So that is equal to, so this calculation approximately gives 0.2 m volume strength of hydrogen peroxide. Okay, this is the volume strength, first part. Next, see the percentage strength. So, the basic calculations we know that 1 normality of hydrogen peroxide is equal to 1.7 percentage. We need to remember these relations as a formula. Then what about 0.05 normality is how much percentage? So here we will get 0.085 percentage. So here the calculation is about to calculate percentage strength and volume strength. So whenever it is asked in the problems, we must know about the normality. By knowing normality, with the relation normality equal 5.6 volume strength hydrogen peroxide and 1 normality of hydrogen peroxide equal 1.7 percentage strength. So by knowing normality, we are able to calculate this strength and this percentage strength. But the point is how to calculate the normality. So to calculate the normality, there is information is given about any reaction. Here it is given reaction with hydrogen peroxide with potassium iodide, where iodide is oxidized to iodine, which is completely undergoes reaction with sodium thiosulfate. In some problems, only these two are given. Then we compare these milli equivalents. Sometimes 3 will given. We compare these 3. Here 4 is given. So 4 substances are given. So we need to compare all this. But we need to consider only those milli equivalents of the substances which are having information about them to calculate N1 V1 equal N2 V2. Okay. Now the point is, so already we said we will calculate the N factor for S2O3. Okay. Now we see what is the N factor in S2O3. So S2O3 minus 2 changed to, then the we must know this, S4O6 minus 2 in acidic medium. So this reaction must be remembered. For balancing we will write this. Here 1 sulfur oxidation number, if you calculate, here totally 4 sulfurs are having plus 2. 4 sulfurs are having plus 2. Here, if you calculate for 1 sulfur, here 4 sulfurs are having 2.5. 4 sulfurs of plus 2 becomes plus 2.5. So the change is 4 into 0.5, that is equal to 2. So this is calculated, we calculated for 2 moles of thiosulfate. But here it is given only 1 mole. Generally equivalent weight we calculate for 1 mole. So therefore, for 1 mole, N factor equal to, that is equal to 1. Okay. Okay, write down. Okay, see the next one. So near to the earlier problem. Here 5.1 gram of sample of hydrogen peroxide solution containing X percentage. So here in this problem the percentage is given of hydrogen peroxide by weight, which requires X milliliter of potassium dichromate solution for complete oxidation under acidic condition. So it is given that an acidic medium. So we need to find the molarity of that potassium dichromate solution. So already we know that the hydrogen peroxide reduces the oxidizes the potassium dichromate. Here K2Cr2O7 is oxidizing agent. Itself it is reduced. Okay, here hydrogen peroxide changes potassium dichromate. The dichromate is changed to chromium ion in acidic medium. Means here H2O2 acts as reducing agent. H2O2 acts as reducing agent means here chromium, each chromium is +6 and becomes +3. Such like two chromiums are doing like this. Two chromiums are reducing from +6 to +3. There is a change in 6 electrons. Okay, means here the H2 hydrogen peroxide works as reducing agent. Means itself it is oxidized. Means here hydrogen peroxide reduces the dichromate ion into chromium +3. So hydrogen peroxide acts as reducing agent. So it depends on the compound and the condition. Hydrogen peroxide works as oxidizing agent, reducing agent. Here it works as reducing agent, means itself it is oxidizing. It is given for this much of X milliliter of potassium dichromate solution is required for complete oxidation of this hydrogen peroxide in acidic medium. So we need to find the molarity of that potassium dichromate solution. So the two are reacted and the reaction is completed one. So we can write milli equivalent of hydrogen peroxide exactly equal to the milli equivalent of the reacted part in the dichromate ion. Potassium dichromate is dichromate ion. Same, N1 V1 equals N2 V2. So normality of hydrogen peroxide is also unknown. Actually we need to find this normality. But even we don't know about this N1. Okay. Now we calculate it separately. Just take it as equation 1. So it is given that 5.1 gram of sample. Just let it here. 5.1 gram of H2O2 solution containing X percentage of hydrogen peroxide, means here given as X percentage of hydrogen peroxide. X percentage of hydrogen peroxide. What does it mean? It means 100 grams of hydrogen peroxide solution . 100 grams of hydrogen peroxide solution has how much amount? X grams of hydrogen peroxide. Means the X grams of hydrogen peroxide is dissolved in 100 grams of hydrogen peroxide solution. Nothing but X grams of hydrogen peroxide is present in 100 grams of hydrogen peroxide solution. The X percentage means that only. So what is the hydrogen peroxide? What is the amount of hydrogen peroxide in 5.1 gram of sample? So here the 100 grams of hydrogen peroxide solution has X gram of hydrogen peroxide. So then what about 5.1 gram? 5.1 gram H2O2 solution has how many grams of hydrogen peroxide? That is 5.1 into X by 100 gram of hydrogen peroxide. Means there is a presence of 5.1 gram, 5.1 into X by 100 grams of hydrogen peroxide is present. Okay, so this much of weight is present. We know the weight now. So with the help of this weight of hydrogen peroxide, we are able to calculate the normality. Weight by equivalent weight. So what is the equivalent weight of peroxide? 34 by 2 means it is 17. So what is volume? Thousand by V. So weight, this is weight by equivalent weight into 1000 by V. This calculation represents the normality and this represents the volume of H2O2. We need to find this normality. And X milliliter of potassium dichromate is given. This we will get cancelled. So this is here again we will cancel this X. Finally we will get it implies this normality and to this normality of potassium dichromate is equal to 3. So this is normality of potassium dichromate solution. So here it is asked that we need to find the molarity of potassium dichromate solution. So we know the relation normality equals molarity into N factor. Therefore, molarity is equals normality by N factor. Normality is calculated at 3. We know the N factor. So what is the N factor? Alright, first we discussed that the dichromate Cr2O7 minus 2 is reduced to Cr plus 3. So there is totally transfer of 6 electrons. This is 1 by 2, that is equal to 0.5 molarity. So normality 3, whereas molarity of potassium dichromate solution is 0.5. Okay, just by equalizing the milli equivalents of both, we are able to know the normality. By knowing normality, we will get its molarity. But here extra thing is just the hydrogen peroxide weight is given in terms of percentage. That with help of that X percentage, we are able to calculate the percentage present in the given sample. Which X percentage clue hydrogen peroxide toni. ఈ 5.1 గ్రాములో ఉన్న హైడ్రోజన్ పెరాక్సైడ్ అమౌంట్ ఫైండ్ అవుట్ చేసినాం. సో ఆ అమౌంట్ ఫైండ్ అవుట్ చేసిన హైడ్రోజన్ పెరాక్సైడ్ అమౌంట్ ఇక నార్మాలిటీ క్యాలిక్యులేషన్ కోసం యూజ్ చేసాం. ఓకే, రైట్ డౌన్. Okay, see the last one based on volume strength of hydrogen peroxide. Here 200 milliliter of acidified means given in acidic medium. 3m normality of hydrogen peroxide is given. This 3NH2O2 is reacting with potassium permanganate solution till there is a light tinge of a purple color. The purple color indicates the color of potassium permanganate, which is also called a deep violet color. So we need to calculate the value of O2 produced at STP. Here, so we know that 3 normality. So what is we need to calculate the value of O2. We know the basic formula that 1 normality of hydrogen peroxide is nothing but equal to 5.6 volume strength of hydrogen peroxide, or it releases 5.6 volumes of oxygen, 5.6 volumes of oxygen. Okay, so nothing but here we can say for 3 normality of hydrogen peroxide is given that how much? So approximately here we get approximately 33 something. Has 16.8 volume of oxygen, or it can be taken as volume strength of hydrogen peroxide. So it can be taken as volume strength of hydrogen peroxide, volume strength of hydrogen peroxide, or volume of oxygen. There is no change in it. Based on the releasing volume only, we give the name of volume strength. That is called available oxygen. So here 16.8 volumes of oxygen is present. Here we need to calculate. So the volume of oxygen released is 16.8 volumes of oxygen. But here it is given 200 milliliters. So we know the relation that the volume of O2 produced, already we know it can be written as volume strength of hydrogen peroxide, and we know the formula volume of oxygen produced is equal volume of H2O2 into volume strength of hydrogen peroxide. So the volume of oxygen produced equal, what is the value of hydrogen peroxide given? The volume strength calculated is 16.8. So here we will get 360 milliliter of oxygen. So this is only released by the oxygen. So this is only released by the hydrogen peroxide. Whereas in the potassium permanganate, already we know in the potassium, the MnO4 minus is also changed to Mn plus 2. Here it is reduced. So in this reaction also there is production of O2 takes place. And as there is a milli equivalence of hydrogen peroxide is equal to the milli equivalence of KMnO4. Therefore, the volume of oxygen produced by KMnO4 is also equal to exactly the same value as oxygen produced by hydrogen peroxide. Therefore, now the total volume of O2 released is from hydrogen peroxide and KMnO4, both are equal. So finally we will get milliliter. Just by making into liters comes having 2 liters of oxygen. So these are the main problems, main models around volume strength of hydrogen peroxide, and even by comparing milli equivalents in those particular reactions. Okay, right on.